Good evening. As the SUI, are you hear me?
Yeah, we can hear it.
Good. So actually I want to talk about adsorption of small hexafluorobenzene on the gold surface. I'll give you some introduction about why this system is important, and then we're going to go through the method we followed in this calculation, and we discuss the result and discussion. I want to show you the partial charge density, and then we're going to conclude what we have seen in this calculation. The first of all, this system is very important. I want to mention benzene and heterocyclic compound has been studied really good in the literature. However, hexafluorobenzene it's kind of a new field, and we study this field is hot and really important in terms of application in industry. For example, petrochemical industry, one of the main reaction is catalytic conversion of aromatic system, which one of them is what we have right now. We're gonna see some of interesting theoretical studies of hexafluorobenzene adsorption in gold and conducting using density functional theory. Um, in this also study, we use VASP, Vienna an issue simulation package, conducted what is supposed to be Dr. Killen, the equation. The equation is supposed to. No, the equation is missed here. Okay, so that's make me relax a little bit. Okay, so first of all, this calculation actually, if we're gonna combine this with the theoretical study, theoretical equation or theoretical running of this calculation, we should remember or call in Cohen-Sham equation, which give you the kinetic energy, give you the potential, give you the energy of the orbital, total density of electrons, how it depend on the orbital, and the orbital functional, orbital equational functional. Determine the potential also, it's depend on the coordinate we have and the density of electron. Orbital adsorption spectrum also involved in this study, which computed based upon transition dipole moment. Here you go. So it's actually different, both of them. Anyway, so we explained them. I don't know why this happened, but and this is the process. We have the position of electron, number of electron, coverage limit. You have the density then, and then you compute it over this matrix. This we have potential here. It doesn't write anyway, and you have can form also or find the kinetic energy and the total density, and then over the matrix, if the total nu minus total less than energy of total, yes, go the output, no, go to, change the density again. Okay, let's go through the what we have did of, using VASP. The first of all, we have three models. The first one of them is the gold hexafluorobenzene, and the third model is combined between both. This is the top view of the left hand side, top view of the picture, and then see other picture. It shows how the hexafluorobenzene away from the gold surface and how the adsorption process is going through. To find the energy of adsorption, we should find the E total, which energy of total system for hexafluorobenzene and gold, and subtract the energy of gold, also the energy of the hexafluorobenzene from the whole energy of the system. We done this over the calculation, and we got thus for all density functional density of states for the whole system. The first picture was showing the Thus, for density of state for C6F6 with hexafluorobenzene, how is the HOMO and LOMO separate together by high gap? And then the right picture is showing the gold surface. As we see, there is no gap in the surface. And then the third picture, I don't like to confuse you, but it's kind of give us the story, which is that there is a combined between the 6F6 and the surface. And if you see, there is no also gap between HOMO and LOMO. If we look to this table, it's give us some of indication how the process go. Number of HOMO of the whole system 561, and for gold 527, for C6F6 33, and overall if you see the total energy is minus 374. It's a little bit far from what we expected, but it's in terms of chemistry, it's logic because this is a favorable process and give us minus energy. That means that this process is favorable in terms of energy. Again, look again what have seen how the energy gap is decreases also minus 0.0878. We draw also the partial charge density for the new system, which has the hexafluorobenzene and the gold, and we draw the HOMO orbital 61, shows how the actually p orbital of benzene, and we expect the d orbital from the gold. And we also, if you see the top orbital, see the effective of absorption different from the down orbital of the from the orbital in the down of this picture. Of this is the LOMO of what we have. We expect to get better results if we run another example. This we know this is information is kind of is not quite well. We hope there is something in the calculation. We maybe highly recommended to run another calculation. Also, I want to tell you about the based upon the total energy here, the binding energy, like it's like minus 49 electron volt. I did not mention here for the in terms of time, but it's also give us that's the binding energy a little bit far from what we expected. We also we highly recommended another calculation based upon this result. This is the movie what we got for the gold surface, showing really good how the movement of atoms. This is for C6F6. To get the highly optimization in, structure. This is the whole system. Yep. How the absorption of benzene, hexafluorobenzene in the gold system. We conclude what we have seen. We used periodic atomic surface of gold as the original structure and hexafluorobenzene as adsorbent, which affect the electron dose. The result indicate formation of several surface states added by the adsorption process. A more accurate calculation is presently in progress. We run time in ahead time to verify if the interaction of hexafluorobenzene with gold surface could offer more attractive result. And I would say thank you.